Good morning, ladies and gentlemen. It is my great pleasure and honor to give you my input on usage of big and smart data in the development of autonomous vehicles. As you already heard, my name is Grzegorz Wyszyński. I'm a sensor algorithm specialist in advanced engineering in Aptiv. I'm one of over 200 engineers working on autonomous vehicles here in Kraków in our company. What's interesting from my educational background, I'm a nuclear physicist. So you can see that everyone can work work with data. I would like to start with a short summary of what I will tell you in upcoming minutes. So I will start with the situation with autonomous vehicles right now. I will show you why I think they are possible right now. And I will also give you an explanation why we don't have hundreds of cars going around without drivers right now in our cities. Well, spoiler alert, it will be related to the testing and safety of the autonomous algorithms. So I will give you some input on the testing, and then I will give you our idea how to solve the problem of testing using simulations. And in the last part, I will tell you some words about our project, which is aimed to make simulations more real life-like. So my company is called Aptiv, but back in 2013 it was still called Delphi. Probably most of you know it by its old name. And in 2013 my company has equipped a car which was a Audi Q3. They equipped it with lots of equipment, sensors, computers, and so on. And the car traveled from west to east coast of the United States completely autonomically. Right now we have next generation of autonomous car. This was prepared for this year CES in Las Vegas in February. Anyone who was then in Las Vegas could have ordered it by a mobile application, and the car would drive for him, and it would take him to his destination. Of course, they had to be driver. He wasn't touching the wheel, but he had to be there to make sure that everything is safe. And well, let's take a short look at what kind of equipment there is in this car. We have LiDARs, short range, long range. We have radars, ESRs and short range radars. We have one trifocal camera, one traffic light camera, and there are antennas for communication and location establishment. And we have two computers again for safety, because you must remember that safety is the most important thing in all of this. So you just from looking at this car, you can say that there is lots and lots of data to analyze. Right now in automotive, it's common for sensors to analyze the data locally. So from each of the sensors, we get the information not about raw data from the sensor, but you get already pre-analyzed data containing information about what kind of object it is seeing or registering using radar waves. But all of these are just testing devices or R&D devices. There is one car already on the market which is available to buy and has autonomous possibilities. It's called Audi A8. This year's model has a possibility to make autonomous drive. You can see the driver here. He's not touching the steering wheel, he's not touching the pedals, and the car is driving by himself in the highway traffic jam. This is called Highway Traffic Jam Assistant, and it is the first, we call it level 3 of autonomy car. It can make decisions of its own, so it can change lanes if it understands that it is a better choice. You can see here that the driver has information about the current state of the surrounding environment. What's more, when the car understands that it will, in few whiles, it will stop to be autonomous. So it understands that there will be how to say it? If the artificial intelligence predicts that there will be a need of driving of human driver, it also gives information on the dashboard, and the driver has 10 seconds to take over the drive. This is different than previous driving assistants like from Tesla. And this is different from the adaptive cruise control, which you can see in other cars. We as Aptiv took part in producing this system. We designed the main computer, which is standing behind all the calculations. We also did some of the sensors for this car. The complete system you can see here on this in this picture. You can see that there is laser scanner. You have seen already LiDARs in the previous scheme. This is the most complicated and most expensive part right now. So that's probably the biggest reason why this system is mounted only in the most expensive Audi. Because, well, this technology still needs some development. We have also ultrasonic sensors, which were not present in the Aptiv autonomous car. But we have also mid-range radars, we have a front camera, which is not a simple camera which only registers video, but it's smart camera, so it has some chip in it, and I will speak about it in a few whiles. We have also a 360 degrees environment camera, which allows you to look at the car as if you were above it, and it makes it easier for you to squeeze into tight parking spaces. Few things about smart camera. This is already one place where artificial intelligence goes into play, because this camera is based on the neural networks to analyze the video, and also it takes some information from the car. This all information gets merged as an input to neural network, and on the output we have list of objects with their speeds. This neural network, as you probably know, this requires lots of data to train this neural network, and this is related to real life driving. Millions of kilometers needs to be driven in a test cars, and then hundreds of people has to sit down in front of the computer and label the traffic lanes or the signs and so on. But you have to remember that there is a very significant profit to it. It's a lot of work, a lot of costs, but the profit is that this sensor is the only one which is able to read the traffic signs, which is able to read on-road markings. And basically, without this sensor, we are not able. The autonomous vehicle wouldn't be able to drive to be a part of traffic. But as always, we are concerned about safety, and depending on only one sensor for such important informations is well, quite risky. So that's why Intel, or in fact part of it called Mobileye, decided to prepare something called Roadbook. This roadbook is based on information gathered from all the smart cameras that there are in cars. Basically, right now, if you have a car which has road signs detection, most probably you have it from Mobileye or a company which uses Mobileye sensors. So there are lots of sensors already in the market for it. You can also buy one for your old car to equip it. So all the cameras analyze the data, then they send it to the cloud. This is very heavily analyzed and compressed. It's only 10 kilobytes per 1 kilometer of driving. This information, this data contains information about possible paths which car can take on this place on the road. And the cloud then merges this data from many sources and prepares road book, which can be put into the autonomous vehicles. There is also one company which does the autonomous cars. This is Google. Let's say they started all this thing several years ago. Right now they are using this nice Chrysler Pacifica hybrid cars. They equip it with 360 degrees camera, which is located here on the top of the car. It looks like a police siren. They have LiDARs here, sorry, and radars which are not visible probably behind the bumpers. Well, because it uses 360 degrees camera, which is located in such a strange place, they have to clean it from time to time, so they decided they will invent such a nice cleaning system, which I wanted to share with you because I think it's very nice. So they have a biggest experience in autonomous vehicles. Their cars have already driven 5 million miles autonomously, which is probably why they are right now at the top of the pursuit for autonomous car. So I think I have convinced you that right now we have already sensors which are available. They are able to, we have computational power which is good enough to drive autonomous cars. We have also algorithms because cars, Google cars have driven 5 million miles. So why are we not yet ready? The biggest issue is the fact. It's issue, but it's also some advantage. It's an automotive industry, and in automotive industry we care about two things: safety and quality. Quality doesn't go much into place here, but we are really focused on safety. That's why we have to test everything 10 times before we apply it into the car. That's why everything is, all the changes in automotive industry are so slow, and so on. Probably if it was for, I don't know, mobile phone industry, we would have already had autonomous mobile phones driving around towns. But automotive is quite different in this particular part. Also, there are other problems related to the testing. In fact, people are very unsure about letting machines take control. Me myself, I would be very stressed. I'm stressed when my wife drives a car. I would be probably more stressed when a machine would drive it. The same thing goes in aviation when we have, because there is also autopilot, which of course takes over control while flying in high level, but starting and landing is taken over by human pilot. Even though the machines are able to do that probably better than a pilot, but the passengers would be more stressed. So that's the same issue here. I have already said about the nature of automotive industry requiring testing. And this is the statement from myself. I believe that automotive cars would make sense only if they were safer than human-driven car. So I think similar thoughts have many people, and we have to convince them that they are safer. And this requires lots and lots of testing, because we know with great confidence how safe are cars with normal drivers, because there are millions of them right now on the roads, but not so many autonomous cars there. That's why we need testing. Here in Kraków, we already test for 15 years car components. We have a big laboratory between Kraków and Skawina. So we know how to test electronic car components. For already 2 years, we are testing sensors like radars and cameras. We also think that this is quite established. Computing modules are similar to the normal body controllers or ECUs. So we can also say that we got it covered. But the whole system, whole autonomous car system and algorithm, well, this is problematic because this requires testing in real life. You cannot predict how other drivers would behave or how the pedestrian would behave. It's a problematic thing, and to get good statistics, it requires lots and lots of real life testing. Our customers already require more than 1 million kilometers of road tests. Just to make an understanding how much is it, it's one car driving non-stop for 14 months with average speed of 100 kilometers per hour, which is, this probably is not possible, 100 kilometers. Non-stop is also not possible because you have to stop for gas. So, and one car is not able to drive 1 million kilometers. So you need to get more cars, probably more time, and this is money. And other thing about automotive industry is that there is, probably in every industry, there is big pursuit for cost reduction. So these real road tests are an most important and most difficult issue right now in automotive driving and this active safety related things. So to reduce the time needed for tests, we propose, and there are works ongoing not only in our company but also in other companies, to use computer simulations for it. The simulations have to reproduce real-life scenarios. We can use them in open loop, which means that the result of our calculations doesn't have an effect on the simulations, or we can use closed loop to test control algorithms of automotive driving. In this case, we tell the simulation what is our decision, and it changes the scenario accordingly. What was my surprise when I arrived in this team is that such a very specific part of software is needed, and there is even competition in this field. We have at least two different pieces of software to do testing, ASM Traffic and CarMaker, and they are just designed to test active safety products. And what you can see here is that they have really nice 3D visualization. They can simulate radars, cameras. After some changes, they can simulate also LiDARs. They even simulate the work of suspension when you turn a car or when you brake. This is really nice, because you have to remember that if you, for example, brake, your car goes like this, and then your front camera will also change its field of view. So this all is covered in this programs. This is very nice, but still it doesn't take into account the one thing, which is the fact that all the actors in the traffic are human people, and you cannot predict, or it's not easy to predict how they will behave because people are different, and this means that we need to include psychological factor into our simulations. That's where the project of which I am part of is being fought. It's called Simusafe, Simulation of Behavioral Aspects for Safer Transport, and it's founded by European Union as a part of Horizon 2020. We are one of 16 members of consortium. You can find us here. We are still under old name because when the consortium was founded, we were not yet rebranded. Most of the members are universities or institutes. There are some producers of biosensors, and there is IBM, who takes care of a cloud part of our system. So what is this program? Oh, sorry. What is this program all about? Well, here you can see the block diagram of the whole autonomous car. You can see that from traffic we read the information by sensors. I have shown you sensors before. All the raw information from sensor is being analyzed using perception algorithms, which then from which we get list of objects separate for each of the sensors, and they have to be fused. So you need to get one total information about the neighboring environment, basing on information from every single sensor. This information helps us understand the situation and then react to it by planning the path that should be followed, that car should follow. Then we have control algorithms, high-level, low-level control for each of the actuators, and the actuators themselves work on changing the state of the vehicle. With star, I have marked places where Simusafe project will have some input. We will work on vehicle environment model, driver behavior model, understanding of situation, and also traffic itself. So our part was to prepare a system for data collection. In this box we have a single board computer which is based on Samsung Exynos microprocessor. We have interfaces to car, so we can read some information from car. And we have interfaces to external sensors like GPS, like accelerometer, like smart camera, and the most important of all, we have USB ports for 3 webcams. 2 webcams are looking at front to the situation on the road, and 1 webcam is registering the face of a driver. This box, together with all the sensors, has to be put into volunteers' cars, their own cars. So we had to make it as universal as possible, because we don't have any we don't have any choice about what kind of cars we allow, and we have to make it as clean as possible, because, well, the owners want their cars after tests to be unchanged at all. So this was quite a challenge, but we finally made it. And there is also one important thing that goes to the USB ports. It is LTE modem, which allows us to send data to the cloud while driving. Why is it important? Because the data from this box will be analyzed on the day-by-day basis by traffic psychologists, who will then decide on 4 or 5 incidents which are of most crucial. We have some pre-processing on the box, so we trigger sending of video on roundabouts, on left turns, on pedestrian crossings, and on rapid braking. So these 4 incidents make video mark video as interesting. It is sent out to the cloud, and then the traffic psychologists sit down and analyze and say, okay, we want to talk with volunteer about this incident. So then once a week, volunteers meet with traffic psychologists, and they discuss about the incident, and then the traffic psychologists categorizes this incident, and then all of the incidents are used for training of neural network to get the model of traffic behavior of drivers. And afterwards, when we get this model, we verify it using simulation in a controlled environment. This is the beta version of simulator. You can see simulation of a pedestrian and simulation of a driver. A pedestrian is seen as a bullet, and the car is white and the wheels do not spin. That's why it's beta version. Here you can see what pedestrian sees in his VR goggles. Here's what driver sees in his monitors. And all the models will be verified using this this simulator. So I have 1 second. Okay. So I have already said that we have large amount of data, around 100 megabytes per hour, but they are pre-analyzed on the board, and they are also and the interesting parts will be analyzed by traffic psychologists manually, unfortunately. But later, all the analysis will be done in automatic way after categorization, and as a result, we hope we will get a behavioral model which will be used as an input to our simulations for testing. To sum up, I think I have already. I think that from technical point of view, artificial intelligence is able to drive a car. The sensors are ready. We have algorithms which are ready, but we have to remember that this whole thing has to be tested to make sure that to confirm that it is safe enough. Also, these tests are needed to convince people that it is safe enough. It's not enough to show, but we have to convince, so we have to be even more safe than it's enough. And to reduce the needed test duration, simulations can be used, and to improve simulations, we use our project to get behavioral models of agents. Thank you for your attention, and afterwards, during lunchtime, I invite you to see our test vehicle, which is parked in front of the building. Then I can show you how our sensors work, and I'm waiting for your questions. Thank you.
Thank you, Grzegorz. It was really interesting. I'm sure that must be really fun to go there as a pedestrian and mess up the simulation environment.
Yeah, yes, definitely.
I'm sure you do that all the time. Okay, so questions, I see. Okay, sorry, first hand there.
What are your thoughts about priorities for safety? Should an autonomous car protect its user at all costs, even when it sees that an accident is imminent? Should it run over and possibly kill other people? Or are there situations in which the user should be put at more risk than the minimum?
This is a hard question, and luckily I'm not the one to make a decision about this. My thoughts are, I come to it from mathematical point of view, so we have to define a matrix which describes how much damage our movement will cause, and then we have to minimize this cost function. Probably it's better to protect pedestrian because he has no protection coming from the, you are behind, driver is behind, I don't know, 1,000 kilograms of mass of a car, and pedestrian is not. But, as I said, luckily I'm not the one to make a decision.
Thanks. Hi. You said that there are like 15 or 16 universities working on this project. Are they competing, or are you working with them?
It's a collaboration. So we are working together. Luckily, there are tasks. Everyone has his own task, so we are not competing at all. We are working together to get to achieve a common goal.
Do you use any high-definition map component embedded in car for your algorithm?
So for our algorithms, we use definitely we use maps. But what do you mean by high definition?
Well, you know, in the past, maps were just used for turn-by-turn navigation purposes, and now some companies are working on high-definition maps, which also might be used for autonomous cars.
Yes,
there are two approaches, right?
As I said before, there is this approach by Intel Mobileye working on the maps to get directly paths on the road, saying that you can drive this path and not the other path. But well, this depends on the information from the outside, and well, autonomous vehicles right now rather are focused on using the information they can have locally, so from the sensors mostly, and probably from the low definition maps to get a brief direction, not exactly the path with accuracy of 1 centimeter.
So you told us you look at the driver's face. What do you take out of that?
Can you repeat the question?
You told us that you connect the camera
Yes.
that looks at the driver's face.
Yes.
What do you take out of that image?
Probably, well, I'm not responsible for it, but I can imagine that from the look on the face, you can check if anyone is, if the driver is relaxed, if he's stressed, or if he is scared. That's my idea, but well, this whole thing will come from discussion with the psychologist. So if he sees that something unusual happens on the face, then he will ask for it, and hopefully the driver will remember what happened 5 days ago. I'm not an expert in it. I'm not sure how much you can tell from the person's face. Yeah, if he's sleeping. Definitely you can tell if he's sleeping or not.
Any other questions? Wow, okay.
Do you think that in next 15 or 20 years driver license will totally obsolete? Or let me ask another way. Let's say our children will need driver license or no?
I think that, well, from philosophical point of view, you don't need driving license right now. But for driving, well, it depends. There are people who say that they will not allow at any costs somebody to drive their car, and well, driving is fun. It's not like it's, of course, it is duty when you have to do it every day at the same road, and there is always traffic jam. And probably for this, we will get autonomous vehicles in, I don't know, 10 or 15 years. As you see, the tech is almost there, and there are works on this, on the improvement of the algorithms and so on. So, well, probably in 10-15 years we will get autonomous vehicles, but I'm not sure if they will become popular. It's question of costs and question of, well, again, people being unsure about letting anyone else drive their own car. But there is a big movement in car sharing. So you will not get your own car, but you will order a car using your mobile app. The autonomous car will arrive at your doorstep, and you will get in, and it will drive you where you want. So it's kind, but then you also will not need a driving license, and maybe this approach will be more popular throughout people. But again, right now we are just at the beginning of the whole journey, and we will see how it will proceed.
Okay, thank you.
Do you know how well autonomous cars behave in winter conditions, like when the visibility of road lines or road curve is reduced?
If we, this is quite a hard question, but basically right now, when you have an autonomous vehicle and it doesn't have all the information it needs, it just shows you the information that you have taken over. The driving, and that's common for all the systems here, because all of them have normal driving wheels and normal pedals, so you can control it by themselves, and the legal requirements are that there has to be a driver in front, if there is a problem, they ask you to take over. If you have a car which has a lane detection system, it is also based on the smart camera looking at the road. Sometimes even if the person can see the lane, the camera doesn't. But there are other way around. Sometimes the person has a problem with seeing the lane, but the camera sees. So it's hard to say. Of course, if it has, if there is snow on the whole surface, there are no lanes. So it has to make a decision about what path to follow, and definitely it will be taken into account, because there are many countries where you don't have lanes directly painted. Not on all roads you have lanes directly painted on the street. So it has to be taken care of in the algorithm design. Well, when you have ice on the road, I believe that the car will behave better than the human driver, because it has information not only from visual sensors, it can not only hear, but it has also information from ABS sensor in all of the wheels, so he knows how fast the wheels are spinning. Basing from this, he can say what the traction is and then correct for this, and maybe even give different power to different wheels to make sure that you are safe. So I believe autonomous cars would help in bad traction conditions.
Did you make any of this data public so I can get my hands on it?
Well, this from our Simusafe project, definitely we will publish all of the data, because it's a requirement from European Union.
Okay, great.
So that's the idea. Of course, the private data like face, video, and probably all of videos and the GPS information will be encrypted, but all the other data will be available, and also definitely there will be some scientific papers coming from it.
And when do we expect that to be available?
We have first phase right now, so my colleagues are already mounting the first sensors. It will take 3 months to gather the data. Then there will be simulations, and there the volunteers will be recruited here in Kraków, and we will do some tests on the test track next year, and probably by 2020 we will get the final results.
Okay, all right. We have time for one more question.
Will the test be performed only in Poland, because there are different traffic regulations and signs in different countries?
Well, so the tests in volunteers' cars are planned to be performed in Italy, in Rome, and in Spain. So there are 2 southern countries. I don't know the reason for it. Maybe they were a bit afraid to make it in Poland, because the drivers are a bit aggressive sometimes here. But the decision was that the naturalistic driving in the volunteers' cars will be done in Spain and in Italy. Then the simulators are, to be honest, I don't remember where, but it doesn't really make any difference. And as I said, the second phase will be done in Poland. We will have simulator here in Poland, and we will also have a test track with a car, and we will do the tests here in Poland.
All right, thank you very much, Grzegorz, for this excellent presentation.
Thank you.